So quick review on rate of change, which you guys know as slope. There are different ways of looking at it. Rise over run, which is how much did you change in the y-axis, how much did you change in the x-axis. There's this little triangle right here, which is actually a Greek letter called delta. So that triangle is a delta. You guys actually might have seen things like, I don't know, like college fraternities, sororities, when they're like, they have the Greek letters and stuff. There's a triangle in it, that's the Greek letter delta. So you might have seen it before. Same thing down here, just different ways of looking at it. Instead of y, they might use f of x. Okay, those are the same as y2 minus y1. Basically, the answer you get when you plug in x, and the answer you get when you plug in the other x, which is the same as y. So a different way of writing it means the same exact thing. So like on example 1 here, we're actually trying to find the slope, basically, of the graph. Now, if you have a graph like this, you can actually count the rise over run and count squares like you always have. We're not really concerned about the shape of the graph so much, but just really pretending that, well, what if this was from -1 to 0? So here's -1, and here's 0. What's the slope of just that part? Just that one part right here, and forget everything else, because we can't find the slope of the entire graph because it's positive, or it's increasing, then it's decreasing, then it's increasing again. So the rate of change will be different depending on which 2 points you pick. So if we just pick these 2 points from here to here, well, that's going to be down 1 over 1, right? That's just a slope of, or rate of change of, -1. Now we can also get that by using the formula. So we can say, well, this is -1 comma 4, and this is 0 comma 2. I think it is, we're counting by 2's, right? And if you calculate the slope using this formula, y is on top, x is on the bottom, we could say the rate of change, and we'll still use m, and we'll get what? 4 minus 2 on the top, the x's, I mean the y's, and on the bottom we have -1 minus 0. So y is on top, x is on the bottom, and calculate that and see what we get. 2 over -1. So I got an answer of -2. How come when I looked at the graph, I got an answer of -1, but when I calculated it using the formula, I got an answer of -2? They should be the same, right? I can't have two different slopes. So how come one's -1? How come one's -2? Any ideas? It has to do with this scale here. What is this scale counting by? Is it counting by ones? No, it's counting by twos. So this is why you don't want to really rely on what I did at the beginning and say, oh, it's down 1 over 1. Oh, it's -1. The formula is probably going to be your best bet. That will give you the most accurate answers. Now, if you can catch on early that they're counting by twos, you can say, well, that's going to go down down 2 and over 1, and you still can get the same slope. But it's, it leaves up all these possibilities for mistakes if you're just trying to count squares. So formula is probably a good way to go. Okay, so let's look at a few more. Let's go from 2 to 3. So 2 would be right about here, and 3 would be right about here. So you want to find out what are the coordinates for those 2 points. 2 comma what? And 3 comma what? Is it 2 comma 4 maybe? I'm just getting that from looking at the graph. Like if I take right here and I go over to the, I'm going to be at 4. And then for here, x equals 3, this would be 18. And then you can use those 2 points to find your slope. So y is on top, X is on the bottom, 2 minus 3. Well, average rate of change or slope will be, let's see, negative 14 over negative 1, which just equals positive 14. So just looking at or zooming into one little part of the graph. Go ahead and do C and D. See how that goes with you, and then check with someone around you, see if you get something similar. All right, so using just a table can be sometimes more difficult, but sometimes easier because you don't have the graph to maybe throw you off a little bit. So if it says from 0 to 1, it's pretty clear that, okay, here's 0 and 1, so we're using, you know, those numbers right there. So I had people say both ways. They either like the table more or dislike it more. Just depends on your personal preference, I suppose. And then you can find the rate of change between those two and the slope. So we'll get, what, 5, I believe, here? Check my math, but I think you get 5. Negative 5? It seems like every time I try to do it in my head, I get it wrong. So good idea to show all the work and prove it, because it can look so simple. Like, oh yeah, it's going to go up by 5. Oh, that's up by 1. So yeah, that should be easy. And then when you actually calculate it, okay, that's 5 over negative 1. That equals negative 5. That's a big difference. Of course, yep. So the slope, I flipped it around. I did 15 minus 20. And I did 1 minus 0. I'd get negative 5 over positive 1, which would still equal negative 5. So slope from any 2 points is the same no matter where you start from. So give the rest of those a try, just finding that interval. Find those slopes over those intervals. Test it with someone next to you, check it just to make sure, and then go ahead and finish up and wrap up the assignment that you got yesterday to include all these questions.